In this video we're looking at the role that lift plays, that is surface-based forcing, in thunderstorm ingredients. You can see that thunderstorm forecasting is a tripod between sufficient moisture to realise cloud, instability to drive the development of convective cloud, and a lifting mechanism to help parcels of air reach their level of free convection. So this tells us when we should forecast thunderstorms, when all three of these things coincide. Here we have an area of potential thunderstorm development. This is the surface lifted index. So it's the difference in parcel, environmental parcel temperature and cloud parcel temperature at 500 hectopascals. And you can see that anywhere below zero is going to be consistent with thunderstorm development. And there's a particularly intense area there where the lifted indices are about -5 or thereabouts. So one might be tempted to forecast thunderstorms throughout that area. Now here's a thunderstorm outlook area that's been shaded in red, and then the pluses and the minuses represent lightning strikes. So it shows you that storms only occur in a fraction of the area of total positive buoyancy. So you can have lots of CAPE, but you don't necessarily get thunderstorms. You need that lifting mechanism. So here's a plot now of the winds for the afternoon. The X's indicate where thunderstorms are occurring, and now the lines indicate regions of convergence, and you can see that in the wind field. So you need these lifting mechanisms to help generate convection. Along the coast there's a sea breeze front where the easterlies push in from the maritime air mass and help generate convection, and then you can see the inland trough or front. And right down the coast there's a southerly change. So what this tells us is we need to know what the forcing mechanisms are on any given day. And analysing in real time, you need to perform a careful mesoscale analysis of the wind field to know where thunderstorms might occur. As you'll see in other contexts throughout this course this year, the position of these features can also dictate where there's sufficient moisture and therefore buoyancy for thunderstorms to occur.